Hey guys, so this is a video on how to prove triangles congruent using two theorems, side 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 and side angle side. So that was developed in an activity either on the computer or using this spaghetti. So by the end of this video you'll be able to label some congruent parts of congruent figures and also prove triangles congruent using those two theorems. So the first thing we need to do is go over the definition of what a side 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 is. Okay, so side, 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 it's abbreviated SSS, stands for side, side, side. It says that if three sides are congruent in one triangle, and they're congruent to three sides in the other triangle, then those two triangles are congruent themselves. So before this, we needed all the sides and all the angles. These theorems limit the pieces of information to three. So in this case, if I know these three pieces of information, I know the whole thing is congruent. So you notice in this picture here, this side is congruent to this side, these two sides are congruent, and these two sides are congruent. So therefore, the triangles, we can say, are congruent. Meaning that if I know these sides are congruent, I can also tell that the angles are congruent, and that all the measures are going to be the same. Now this picture is here because we need to identify some things in some pictures. One of those things, okay, we notice that those two pairs of sides are congruent, but we don't have like a third pair. But what you have to notice is that this side right here is shared between the two. So it's automatically congruent to itself. It's called the reflexive property. Really, it's just a shared side. So we can mark it congruent. I usually mark it with 3 tick marks. It could be 2, it doesn't matter how many tick marks. So that means that that side is congruent. So these sides, this triangle is congruent to this triangle by side, side, side. The other theorem we have is side angle side. And it's very important that when I say side angle side, it is in that order. The angle is in between the two sides. So here, again, you see the shared side here is marked congruent. I have these two sides and this angle in between them. So the side, the angle, and then the side, it's in that order. So to use this theorem, SAS, okay, it's if two sides and the included angle. The included angle means the angle between. Okay, so it's between those two sides. If those three pieces of information are congruent to these three pieces of information in the other triangle, then the triangles themselves are congruent. I can also have a diagram like this. You notice that vertical angles are congruent, and that angle is in between those two sides. So it's side, angle, side. To get a little practice on this, we have these examples. So one of the first things we need to do is identify what information we have. Okay? Well, this arc is an angle. Okay, this tick mark is a side, and this tick mark is a side. I can also label the same thing here. Now, what I'm deciding is, are these pieces of information the same as these pieces of information? Okay? So, you'll see that it's an angle, side, and then a side. While this one is a side, then an angle, and then a side. So you notice that they're in a different order. That means these triangles are not congruent. And remember, that symbol means congruent. Okay? So it doesn't fit into my side, 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 or it doesn't fit into my side, angle, side. In this, okay, I'm given a side, I'm given this 90-degree angle, and then this other side. So side, angle, side. Does that match this? Side, angle, side. Yes, it does. So I would say triangle DFE is congruent to triangle JHG by side angle side. So that's how you would answer that question. For C, I have to look at it and I have to say, oh, what do these arrows mean? Well, those arrows mean parallel. Okay? So if that means parallel, I know that angle 1 and angle 2 are congruent because they're the alternate interior angles. So we have to remember that stuff when we're going through this stuff. Parallel lines have congruent angles. Okay, alternate interior or corresponding, that sort of thing. And that gives me a side, an angle, and then another side in both triangles. So I would say triangle PQR is congruent to triangle RSP by side angle side. Because I knew that that angle, that was the included angle. So, to get a little bit more practice on the included angle side, okay, all you're doing is naming the included angle, or the angle between. Okay, so the first thing I want you guys to do is draw triangles. That's the easiest way. Now I'm going to say, okay, in this first triangle, it says MAT. So I'm just going to label it MAT. And I'm looking for the angle in between MT, I'll put a tick mark there, and TA, this one. Well, the angle in between that side is this angle right here. So there's two different ways I can name it. I can say angle T or angle ATM, as long as T is the vertex of that angle. I can do the same thing here. CDA. Okay, I mark CA, I mark DC. So the angle between them is here. So that's angle C or angle DCA. And I can continue this for these next two. This is where most people have the trouble, is if we want to decide if there's enough information to prove if these triangles are congruent. So they tell you which triangles they are, okay, and they give you a diagram. So the first thing you want to identify is any shared sides, anything like that. Well, they share this WY here, right? So I'm going to mark that with 3 tick marks. Now you notice that this side matches up with this side matches up with that side, and I have this shared side. So it's a perfect demonstration of side-side congruence there. So I would say triangle XYW is congruent to triangle ZWY by side. And I'm done with that question. For 6, I again mark this AE because it's shared. But now I look at it. Okay, I don't have that third side marked and I can't assume anything. So side's up. Well, now I'm looking for side angle side. Well, to be side angle side, I would need this angle in between here. That MAE or EAT, that angle right in there. I know this angle out here. And it's not in the correct order. It's not between. So these triangles are not congruent. Because that angle isn't between the two sides that are marked congruent. Unlike 7, where I can mark this JK, and you'll notice that this has an arc, and that is the angle. Or that is the other side. So it's side, angle, side. And it matches up with this other triangle on the bottom. Side, angle, side. So I can say triangle KHJ is congruent to triangle KLJ by side, angle, side. These are just more examples of These are just more examples of the same thing. Deciding, okay, do I have enough information? I have those two sides, I have the angle in between, and then those two congruent marks. So, triangle DKA is congruent to triangle TKS by side, angle, side, because I don't know that third side. Here, I know this angle, I know this side, and I know this side in both triangles. But is that angle in between the two sides I know? No. So that is not congruent because it's outside the two sides. It has to be in between. And then this, again, I always have to mark that shared side, that fully shared side. Okay? And I have the angle. If this is 90 degrees, the other side is 90 degrees. So again, I'm left with side, angle, and then side. So triangle TRA is congruent to triangle GRA by side, angle, side. So that's how you prove triangles congruent using side, 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 and side, angle, side. Please try the practice problems for this and check with me if you have any questions.